So, when we are solving by factoring, similar to some stuff that we did before. As always, when we're factoring, the golden rule always applies. If there's something that each of my terms has, I need to take that out first. And I'm going to kind of stress that up here at the top. So for instance, both of my expressions here are divisible by 5. And if I do that, I'll factor that 5 out. But here's what I have to be careful of. Once I do that, that's not always going to be everything that I can do. There may be some occasions where, I might be able to factor what's inside the parentheses. Can I this time? Yeah. Because I noticed they're both perfect squares, so I'd be working with a difference of squares on those. So if I factor out my difference of squares, what am I going to end up with? They're like, yeah, I square x to get x squared. I square 2 to get 4. And since I want them to multiply to negative 4, I get one of each. Okay? And that's as far as I'd be able to go with that one. Because once I lose the quadratic part of it, there's nothing else I can do. But on each of these, up above at least, anything in common with my 3 terms in number 2? 3. So I take that 3, put it in front, factor it out. Get that worked in here. Now this time, I'm going to have a little bit of guess and check to play with. Now it won't be a ton, because I know I have to have 2p and p, because I don't have any other options besides 2 and 1 for 2. I don't have any other options besides 3 and 1 for 3, but I do need to pay attention to where I put them though. So which one's going to be going in with my 2p here? Yep, the 3 is going to go here, because when I FOIL it, I get 2p for my outside and 3p for my in. So 2 plus 3 is 5, and that one's good to go. So all right, difference of squares, okay. Guess and check 1, okay. What do we have in common on number 3? 2a. Because they both have a variable term. So this time I just go, oh, okay. I already got the 2. Got 1a, I want to get a squared, so a. 2 times 4 is 8, and I already have the a. I don't have a quadratic anymore. I don't have a squared term. So all I can do that time is take out the common factor. So that's an option. And then finally, my last option, I guess, of sorts. I think it's kind of obvious what they all have in common. So you're like, okay, this is just going to be another one of those problems where I play a little guess and check. But I start looking at this for a minute, and I'm like, okay, so this, and I'd get my parentheses set up. Now I'm starting to go along, and I'm like, well, wait a minute. If that's got to be negative 1, that would mean 1 has to be 1 and 1 has to be negative 1. But I think that's going to cause a problem. Okay, so x times x is x squared. Okay, negative 1x and positive 1x cancel. I don't have any x's left. Well, wait a minute, that doesn't work. But just switching them doesn't work. Oh, I guess that's not factorable. Okay. So that can even happen. It can just be where you get that one factor coming out. It's still a quadratic, but I can't factor it. So you may have some options coming here. So the only thing we're going to add to that today is the fact that now there's an equals 0 there, which means we're actually going to find the solutions that I could plug in for x that would find equality. So if we bump up a little bit, we're going to have the same mixture like we did up above of different types. Here I'm like, okay, straight up guess and check. I know these are both x, so I need them to add to 3 and multiply to negative 18. But again, there's even clues in that. If they're going to multiply to a negative, I know one's plus and one's minus. If they add to a positive, I know the positive number is going to be bigger. So what are the two numbers going to be that I'm using? Perfect. Okay, 6 and 3. A quick double check. Yep. And the only difference now is going to be, instead of saying I'm done with the equals 0 there, I'm going to take each quantity, each set of parentheses, set them equal to 0, and solve those mini one-step equations. And if I were to plug each of those back in for x, I'd get values that would work and make the two sides each equal 0. It's not like some of the others where you're going to get incorrect answers unless you factored wrong, but you won't get ones that don't work. The only thing to really be careful of on all of these is making sure that it equals 0 before you start. So like for instance here, I would need to subtract the 3r and add the 5 over so I can have my equals 0 that I can solve. So subtract the 3, add the 5. So once I get everything on one side, anything in common? 2. And then I'm going to attempt to factor whatever is left in the parentheses. So I know that's r. I know plus 25 is negative and negative or positive and positive, but the middle tells me it's negative, negative. What are my numbers going to be this time? 5 and 5, because 5 times 5 is 25. 5 plus 5 would be 10. And if you get the exact same quantity here, you don't have to do it twice. And some people even say, well, what's up with the 2 then? The only way that 2 would come into play is if I'd have factored out like 2r. If there's a variable with a term, I have to set it equal to 0. If not, I just don't worry about it. Let's see here. Let's play around a little more. Number 7. Anything to take out? 2. Now, I might even suggest something a little more than that. I might even suggest negative 2 because it's easier to have your b squared value be positive when you're factoring than have it be negative. And the only change that'll make in here is it basically is going to change signs because negative times negative is positive. Negative 2 times negative 30 is 60. And now again, that negative 2 really isn't going to come into play anymore. But I am going to need to factor what's left in the parentheses there. So let's see. I know I get a negative and a positive because I have a negative product. I know the negative number is going to be bigger. So what goes where? Negative 6, positive 5. Negative 6 plus 5 is negative 1. I'm good there. Unique quantities. So I'll set those each equal to 0. And get my 2 solutions from my quadratic. Let's see, what else looks different? What else looks different? Well, 8's different. 8's a binomial term. Nothing in common. What am I going to do with 8? What do you notice about each of the values in 8, the 4 and the 25? They're perfect squares. So what do I square to get each of my terms? Like we're too busy writing. Square 2x to get 4x squared. Square 5 to get 25. And again, with these, they're unique. So I'll set those each equal to 0. And again, this is just a personal preference. Typically, with anything you're looking in, you're going to see answers as improper fractions like this. But if you wrote 2.5, negative 2.5, or negative 2.5, 2.5, that's okay. My answers will just probably be going up this way. Just a fair warning. Let's find a couple that are different here, and then I'll get going to the next part. Let's look at 10 and 12. And we'll kind of see where we're going here. All right, 10, anything in common? 8x. So just like we had before, I already got the 8. I have an x, I need to get to x squared, so I need an x. 8 to negative 24 is minus 3. I already got the x. Here's the situation we were talking about up above. This time when I pull out my common factors, I had an x with it, so that will be set equal to 0 as one of my solutions. Only when there's a variable attached. And I get 2 solutions. So again, as we're doing these, I don't see anything in common in 12. And even I'm smart enough this time to go to a pencil because I remember, I'm like, oh, now 15 could be 15 and 1. It could be 3 and 5. Now 3, that's not a big deal to deal with. And I can sort of visualize here how this is going to work out already. Because I'm looking at the 3 and 5 and the 3 and 1. I'm like, I need to get 14. 3 times 3 is 9. 5 times 1 is 5. So 9 plus 5 is 14. So I'm like, okay. So I'm like, let's see, I want 9 and I want 5. 9 and 5 multiply to a positive, add to a negative. They're both negative. And again, if sometime you need to just play and put the numbers in and use an eraser and erase, that's all right. Nothing wrong with getting fractions. And I get my solutions. So as long as you're always looking to see first if there's something you can factor out, and then factoring with whatever you have left, you should be in good shape. Now, when we go to trying to write these in standard form with the given zeros, think about for a second when you're looking back up above at the examples what relationship your answers have to the quantities you get before them. So we'll do something a little simpler, like with number 5. X plus 6 became negative 6. X minus 3 became 3. Basically, they're opposites. So when I look at these, when I'm going to write the quadratic out, in other words, I'm going to expand it back out, positive 2 would get me a minus. Positive 3 would also get me minus, because if I were setting those equal to 0, well, I'd add the 3, I'd get 3. I'd add 2, I'd get 2. But write the quadratic means I have to FOIL this out. So once I get my 2 quantities figured out, I'm going to go ahead and I'm going to FOIL this out. Combine my like terms. So basically what I'm doing is I'm going from the answers back to the original problem. Up above in the last section, we were going from the original problem, finding the answers. So we're just reversing everything. Now it gets a little more interesting when we start getting into fractions, and I've got a way to help you clean that up a little bit. So you're like, okay, this would be x minus 4 and x minus 1/2. Now we don't do a lot of stuff with fractions in these. So here's how this is going to clean up. If I think about that with the ones where I got fractions, let's say like number 12, I'm like, oh, so basically it's I had a number and then I was dividing by this. I can do that backwards. Whatever that denominator is, if I swing it back to the front of that particular quantity, because you're like, oh, because if I set that equal to 0, I'd add 1 and then divide by 2. That's where the half would come from. Okay, so that's how I get it back to this form, and then I can FOIL it out. And of course, combine like terms. And then similarly, in 16, sort of like what we did with the half here, I'd have my x minus 3 halves and my x minus 4 fifths. And if I'd have had a negative here, I'd have plus inside. I'm going to swing those denominators back to the front. And then again, FOIL my two binomial terms out. So it's kind of cool that we can take the problem all the way to the answer now and come up with a problem for it and work those backwards. So again, it's more understanding the language there. Write a quadratic in standard form. In other words, get it back to your x squared type format when we're doing those. So then, and again, just a couple of reminders back here, and then we're not going to work through all of these because it's getting kind of repetitive for some of these at a certain point. This is what I want to keep stressing though. Make sure that if you do have a problem that isn't equals 0, that you get that set first. And once you get that set, then you can go ahead and factor what you have left. Let's see here. Negative means I'm going to have one of each. Positive is going to be bigger. 5 and 2 sounds like a plan. And once I do that, I just set each of those equal to 0 and get my two solutions. So you're like, okay, done the factoring, set them equal to 0, working backwards, what you got left? Two minor things. One is actually using it for an application. Okay, find the dimensions of the figure. Area of a rectangle is 36 square feet. How do you find the area of a rectangle? Okay, base times height, length times width, however you want to do it. They give me what the area is. They give me the length. They give me the width. So here, I want to get to the equals 0 part. So I'm going to distribute here on the left. And I'm also going to move the 36 over to this side because I'm going to do some factoring. So distribute it through, bring the 36 over so we have equals 0. Factor what you have left. Let's see here. We got a negative and a positive. Negative's bigger. What are our two numbers this time? Multiply 12 and 3. So I set those each equal to 0. And then I say, now wait a minute, I got to use a little common sense here. I'm looking for sides of a shape, lengths of them. Negative doesn't make sense. I can't have a negative length. So I find out that x is 12, but that's not the final question. Find the dimensions of the figure, mean I actually have to stick the 12 in. So my x there would be 12. 12 minus 9 is 3. Those are my dimensions. and I would do that on each of those. It's just set up length times width, get it on a side, kind of work it out. And the one thing we haven't talked about yet is factoring by grouping, because we've had 2 terms where it's a lot of times it's a difference of squares. We've had 3 terms where we've done guess and check, or if you've done diamonds before, maybe those. But now we've got 4 terms. What the heck? Okay. When it says by grouping, most of the time, not every time, most of the time you can just pair these off in the order they're in. And what you're basically going to do is you're going to factor out the greatest common factor for each pair. And what'll tend to happen is whatever you have left over is the same for both. So let's see if this works. What do these two have in common? 4m. So let's see what we got left here. We've got, what's going to be left inside my quantity here? Because I've already got the 4, I already have 1m, and I need to get to 2, so I need one more. I already got the 4, I already got the m, I need the p. So if this works out right, when I factor the next one out, I should end up hopefully with m plus p in the parentheses here. Let's see. I've got a 3p in common this time. They both have 3p. I got the 3, I got the p, I need an m. I've got the 3, I have 1p, I need 2. And so now you see what I mean. Those should be the same if I've done this right. And then to finish, you combine the terms that are outside of your parentheses, and then I use what they have in common, but I only do it once. And we're going to do a few of these because these are a little different. But again, typically, and if you're a person who uses pen, you're going to find out here in a minute, you may want to second think that. What do my first pair have in common?
3.
Okay, 3. Anything else? X. All right, so 3x. 3 times 4 gets me to 12. I already got the x. I need an a. I already got the 3. I already got the x. Need a z. So then I move to my other pair. I got a y. Got the y, I need 4 and a. Got the y, I need the z, and again, they're the same. This is great. Pair up the 2 that I factored out, and pair up the 2 that are alike. Okay. Last couple we're going to take a look at are 30 and 33. Again, until further notice, I'll just keep pairing them up in the order they're in. Now, I always have the right to move terms around if I want to. I'll still get the same answer, but so like here, we have an a that we have in common. I got an x and a plus y left. Now, if I look at something and it looks like I don't see anything in common, I still can pull something out. I can pull out a 1. I got to pull out something. So if there's nothing else, pull out a 1. I end up with x plus y again, which is good. They're the same. I got a plus 1, x plus y. And we're good to go. Now here comes the one that gets a little tricky, and I'm going to use a pencil at the start to kind of show why. If I just get in the habit that it always has to be the first pair and the second pair. So like I look at this first pair and I go, okay, I can pull out a 4. Ooh, that's it. That's all I can pull out is a 4. So I start writing everything else down. I'm like, that's a whole heap and a lot of stuff. I look at here, I'm like, no. Well, wait a minute. There's nothing else I can pull out, and these aren't going to be the same. What's going on? This is a case where I have to back up a little bit. And I go, okay, maybe rearranging these into a form it looks like where there's more things that would be alike might be a better idea. So maybe I look and I say, well, these both have d squareds and these both have c squareds. That might be an idea. Or maybe I look and I say, well, these both have x and these both have y. Just find something that your pairs would both have in common and do it that way. So let's go back. Let's say I've noticed my c squareds here. So I'm going to rewrite it. And again, keep your signs the same if you're going to rewrite. And there's not always going to be one way you have to go with this to make sure that it works. So now let's see if this works better. 4 and 6, and 12 and 16, I can take out a 4 and a c squared. What have I got left here? I got 3x minus 4y. Okay. So then I look at my next pair. 3 and 4, can't take anything there. Oh, I can take a d squared. Let's see. Now I've got 4y minus 3x. Wait a minute. That's close. Is there some small change I could make? Yeah. If on that second one, let's say instead of plus d squared, I made it minus, because then I could change the signs on both of these, and now it is 3x minus 4y. This one's even going to get one more kicker here in a minute. So I'm like, okay, let's pair these up. So 4c squared minus d squared, and 3x minus 4y, and you could even write it this way if you wanted to. They're the same. Here's one new situation we haven't come into yet before that we need to be aware of. There may be, on rare occasion, the opportunity where one of your two quantities can be factored again, depending on how things work out. These are both perfect squares. It's a difference of squares. So here on this one, I actually have one more step. So I'm like, wow, what do I square to get 4c squared? That'd be 2c. What do I square to get d squared? That'd be d. And I know since it's a difference, it's plus minus, and this other one will stay the same. So before you give that final circle to an answer, always look at your quantities and say, okay, is there something quadratic? Is there something squared that I can still mess with? Because sometimes there will be. So the assignment that goes with would actually be the next homework check, not tomorrow's of course, but the first assignment in homework check 8. And like I said, tomorrow is just going to be a day to work on the quiz preview, get questions answered, and if you need some time to work on this, you can. Okay? And that's kind of the route that we'll go with that.